Hello again, and welcome to the end of Chapter 5. We've got a kind of a tricky problem right here, and it's a really interesting problem actually. And wrap up a couple of geometry things, and then we'll be done and ready to move on to Chapter 6, hopefully. This particular question says, it says to determine the number of deer in a forest, a conservationist catches 612 deer, tags them, remember that, and releases them. Later, it says 244 deer are caught, and it is found that 72 of them are tagged. Estimate how many deer are in the forest. Well, let's take a look at what's really going on here. Let's just say, pretend you've got this big giant area, and you have all these deer, and you don't know, the area's too big, you can't go through and count them. So you decide that you're going to just randomly catch a whole bunch of deer and tag them and then release them. So you make it all around, tag them. So they tagged 612 deer, okay? And then they come back later and they start all over again, and they just start randomly catching deer. And of the deer that they catch, they simply count how many of them have tags and how many don't. So when they did the second part there, they found that they had 72 tagged deers out of the 244. Okay, so again, before they did this, they caught 612 deer and tagged them, put them back into the population. And then they waited, then they went around and randomly catched another 240 deer, and out of those 244, they found 72 with tags. Okay, so think of it like this, think of it, if you recall a fraction, we talk about part over whole, a fraction. Well, in this particular case, they found 72 deers with tags at the end out of 244 deer. Okay, well, then if we go back to the beginning, again, what they're trying to find here is they're trying to estimate the population of the forest. Now, it's not going to be exact, but they think they can get a close idea of how many deer there could be there. So they found that out of 244 deer, 72 have tags. Okay. So the goal is to find out, well, how many total deer are in the forest if they had tagged 612. Okay, now notice how I use the labels to match, if it's the numerator or the denominator. So if the part of the sample that they took was 72 tags out of 244 total, then if the part was 612, which is all of the tags, what would the whole be in that proportion? And that's how they're coming up with this estimate here. Now, if you notice, you now have your proportion, and we're just going to crisscross, multiply, solve the problem. So there's 72 times x. And then we multiply this 244 times 612. That comes out to be, I got 149,328. And then let's just go through the process of solving that. Divide it by 72. And that comes out to about 2,074 total deer. So again, it's just an estimate, but it gives them an idea. Maybe that's a pretty good guess of about, probably have around 2,000 deer in that particular area. But a really neat application, I think, of proportions to another type of problem. And I believe you'll run into one like that in your homework as you move along. So let's move on then. We're at the bottom of page 12 here to geometric applications, a couple pages, and we'll be done here. Well, in section 5.5 at the end there, they start talking about similar figures. So basically a similar figure, basically two figures that have the same shape. Now, what we know that the lengths of similar figures, the lengths of the corresponding sides. That's kind of like the sides that match, and we'll see that in the next picture. The lengths of corresponding sides have the same ratio, or in other words, they are proportional. So if you compare the ratio, if you have two shapes that are similar, it's basically the exact same shape, but one of them is larger. If you compare the corresponding sides of one pair of corresponding sides, it would have the same ratio as another pair of the corresponding sides. So it sounds confusing when we talk about it. Let's look at an example here and see if it makes a little bit more sense. Here is page 13 in your notes. So it tells you in the problem, it says that the triangles below are similar. So since they said that they're similar, we know that corresponding sides are proportional. The ratios are equal. So a corresponding side, like this length right here, 21, okay, that corresponds with this side right here. Okay, so that's corresponding sides, and you can kind of see it by the way that the picture is laid out there. So the corresponding side of x would be 9. So we know that if they're similar, that the ratios of those are equal. So the ratio of x and 9 is equal to the ratio of 21 and 7. So the ratio, here's what we just said, the ratio of x over 9, that's a ratio, right? X over 9 is equal to 21 over 7, right? X over 9 is equal to 21 over 7. Now notice since I put the x on top here, from this shape, I have to put, and I put it right there, I put the x in the numerator, then you have to put this number in this numerator because it's from that shape. If you reversed one of them, it wouldn't work. Okay. Now from here, we're just going to do our crisscross trick. It's 7x is equal to 189, and we're going to solve that, divide by 7. I'm going to run out of room down here, so I'm going to move over here. That 7 divides out. Remember how that worked. And 189 divided by 7. That leaves me with 1x is equal to 27. And that's it. Okay, so those are corresponding sides, and it doesn't matter what the shape is. If you know that two shapes are similar, you can always match up the corresponding sides. Let's do the last question here, and this is kind of a famous type of a question. It was probably on the math placement exam if you took that. And it's the flagpole shadow question. How high is a flagpole that casts a 56-foot shadow at the same time that a 6-foot man casts a 5-foot shadow? So pictures are great for this. Now I can use my computer and create this cool picture here. If I were doing this on a test, okay, I would do the same thing, but I would, if I were you in your notes right now, I would be drawing your picture like this. Call that 5-foot, call that 6-foot, and then draw a bigger one here and label it these measures like this. So again, the 6-foot man casts the 5-foot shadow, so that's this part. And then the flagpole casts a 56-foot shadow. And what is it we're trying to find here? We're trying to find how high the flagpole is. So the flagpole height is x. So if we imagine this dotted line on this triangle, and here it's kind of like you have two similar triangles. But the truth is we have everything we need because these are corresponding sides and these are corresponding sides. So we have everything we need to write a ratio using corresponding sides, like x over 6 equals 56 over 5. Did you see how I did that? Corresponding sides, x over 6, 56 over 5. Right, now just do the math. You got 5x here. That's equal to, I believe that works out to be 336. Solve it for x, divide by 5. You're going to get a decimal here, and that's okay. 67.2, and they told us feet. So there you've got the solution to the flagpole question. So that's going to wrap up Chapter 5. Congratulations if you've made it this far. and we will soon be working on Chapter 6. Have a nice day.